Woo! Aren't shortcuts great? I love the shortcuts. Now, because we have shortcuts, we get to complicated formulas like this next one here called the quotient rule. Okay, much like the product rule where you had two functions being multiplied together, the quotient rule requires that if you have two functions, again, u and v, okay, are both, all right, they're both functions, and they're being divided by each other. So how can I possibly find the derivative of this? Well, again, we have a rule that goes with this, a quotient rule, and it looks very complicated. And it would be like the way I would say is the derivative of the bottom one times the derivative of the top minus the top one times the derivative of the bottom all over the bottom one squared. You can see that right there. Now, that's a kind of a boring way to do it. My personal way that I like to do it is I like to do it this way. And I'll go, well, it's low-de high minus high-de low all over low squared. You say, wait. These have nothing to do with each other. Well, it kind of does. Look, low, okay? So if you want to rewrite this out, it'd be low times the derivative of the high, d high, derivative of the high minus the high times derivative of the low all over low squared. Now the thing is, as long as you label this one high and you label this one low, and the rest of it goes from there. And this is something you have to memorize. This is no getting around this one. This is a memorization thing. You have to memorize this one. All right. So let's see it in action. Okay. Here you go. So I want to differentiate this and then support it graphically. We'll get to the graphical part later. So let's do this. I'm going to call this one, this one is high. This one is low. So here we go. Low-de high minus high-de low all over low squared. I'm just writing that down so it can help me out. So low. So whatever low is, so I write that down. So I would say f prime of x is equal to x squared plus 1. That's the low. Times the derivative of high. Well, the derivative of the high one, okay, is x squared minus 1. Derivative of high is going to be 2x. It's just 2, right? Power rule. Minus high d low. Well, the high is x squared minus 1. The derivative of the low, again, is 2x. All over low squared. X squared plus 1. So x squared plus 1 was my low, and I'm squaring it. All right, wow, that looks like a lot. So now all we have to do is distribute and do our algebra part here. So this is all equal to 2x cubed plus a 2x, okay, minus the quantity of 2x cubed minus a 2x all over x squared plus 1 squared, which is finally going to equal, well, the 2x cubes will end up canceling themselves away. And then I've got 2x minus the negative 2x, so 2x plus 2x, so this can be 4x all over x squared plus 1 squared. I'm going to do that as f prime. That's what my f prime of x is equal to. Notice I didn't expand the bottom because it makes it easier for the proving graphically part, or proving, okay? So let's go to my calculator, and I've already preset it up. So if you need to pause the video to get everything set up, here's the order. y1, this part right here, is my function that I typed in, x squared minus 1 divided by x squared plus 1. And then what I have is down here y2. y2 I have as being the derivative of y1. And then y3 I put in the function that I got, which is 4x divided by x squared plus 1 squared. Okay, so I took off the equal sign here, I took it off so that the only two being graphed are y2 and y3. Okay, and if I did this right and I was able to find the actual derivative, they should look the same. So I hit graph. Now look at it's the same. There's one graph, right? And how can I even see it's the same? If I go over here and I go to the table, they show me here the outputs of y2 and y3, and look, for every x value, the same y values. And this is where you've got to just drop a little bit and be like, holy cow. Because this is more than just algebra, guys. This is, take a look at this. I come back over here and I need to appreciate what I just found. I took this complex function, x squared minus 1, and divided by x squared plus 1. Complex. Looks horrible. I did some math to it. Did some rules. I was taught how to do rules. I got this function down here. And now every time I input a number, I'm getting the slope at that point for the graph. Wow! How crazy is that? And how cool is that this is something that's not too terribly difficult, and yet you're able to pull off this stunt that is amazing. You got to think back and just go, wow, what you just found. All right? So let's take a look at it, another one. Okay, example 6. It says let y be u and v be the product of the function u and the function v. Oh, look, product, function u, and v. Find y prime of 2. Oh, so look, it's a product of two functions. Product of two functions. I wonder which of my rules I'm going to use. Product rule. Okay, remember product rule. Y prime is going to equal, leave the first one alone, take the derivative of the second. Okay, plus leave the first, take the leave the second one alone, right? Okay, leave the second one alone. Okay, v, and times the derivative of the first. Now notice I didn't do dv dx or du dx because I kind of simplified it a little bit, right? So now if I want to find y prime of 2, okay, y prime of 2 is equal to, okay, u of 2 times v prime of 2 plus, check up here, v of 2 times u prime of 2. Now it's just a matter of plugging and chugging in. So y prime of 2 is equal to 3 times 2 plus 1 times negative 4, which is equal to 6 minus 4, which is equal to 2. So sometimes it's good to find a puzzle. Y prime of 2 is equal to 2. Not too terribly difficult, fairly straightforward, but if you don't see an example of it, you are going to go, what do I do? Now you know. Next part. Okay, so we have our last rule, or basic rule, last basic rule of differentiation. And this is the power rule for negative integers. And if you were to flip back through and see this, all right, into the original, the rule number 1 or rule number 2 about power rule for positive integers, it's the exact same rule. Don't ask me why they're sitting down there having two different rules. It doesn't matter. Same rule. Okay? So now watch this. So I come over here and I do bink. It says, so why do I know this rule? So it says, find an equation of a line tangent to that curve. Support your answer graphically. So here's what we're going to do. So when I take a look at this one, I'm almost thinking, well, wait, I have a function u over a function v, two separate functions dividing by each other. Oh gosh, I have that complicated product rule. But here's kind of one of those exceptions, because you have to remember what a fraction is, right? It's one of those exceptions is with this being a monomial or a singular one, no adding or subtracting by it, I can rewrite y as being x squared over 2x plus 3 over 2x. And that's just because this is a monomial. Okay? Now, and so I'm able to split it up nice and easy like this. You can always split up fractions, but it doesn't come off as pretty as this because I can simplify this right here as being y is equal to x over 2, okay, plus 3 over 2x. Now, again, this may seem like, okay, well, how is this going to be a power rule? I've got x's on top, x's on the bottoms. So you again got to remember about our fractions and how they work with variables. This is the same thing as saying 1/2 times just x to the first power plus, well, if I have an x in the denominator, that means it's to a negative power. So it's the same thing as saying 3/2 x to the negative 1 power. So now I'm ready to now I have it all set up to where it should be an easy power function rule. And so this becomes y prime. I want to take the derivative now. X to the first power, so this becomes 1 times 1/2 is 1/2. 1 minus 0 is 0. X to the 0 power. Plus, multiply it by a negative 1, so negative 1 times 3/2 is a negative 3/2. X negative 1 minus 1 power. Okay. So I do this, simplify this here. Anything to the 0 power is 1, so it's 1/2 minus 3/2 x to the negative 2 power. And that's just for the derivative. So what I need to find now, they want me to find the equation of a line tangent to that curve. So again, what do I need for an equation of a line? I need a point and a slope. The point they give me, 1, 2. They already did half the work for us. The slope, so now to find slope, I need to find y prime at 1. When the x-coordinate's 1, I have what y prime is. Okay? So in this case, y prime of 1, get a different color because I like different colors. Y prime of 1 is going to be equal to 1/2 minus 3/2, which is going to equal a negative 1. So my slope is equal to a negative 1. So now I've got my point, I've got my slope. So what's the equation of my line? Y minus 2 is equal to negative 1 x minus 1. So then the question comes, well, how can I support this answer graphically? And this is what I'm going to ask you to do in your calculator without me doing this. Okay, so what I would like you to do is I want you to go into your calculator, I want you to graph this equation. You either can graph this one, or you can come over and do this one, put this in your calculator. Okay, doesn't matter, either one of those. Put that into y1. Okay, then what I want you to do is I want you to put this equation into y2. Solve this equation for y, so make this y is equal to negative 1 times x minus 1 plus a 2. Put this one into your second equation and see if that line ends up being tangent to your original equation. And I want you to pause the video right now and do that. I want to see if you get that tangent line, show that graphically. I don't have the time in the video to do it. Okay? Pause. Do it. Pause. No, really, I mean it. Pause. All right, well, I'm glad you did that. Hopefully that worked out for you. Hopefully you got to see that those two came together and worked together. So now it says here, find the first 4 derivatives of this equation. What, 4 derivatives? I can have more than one? Yes. Okay. I can have more than one. So here we go. Y prime. That means the first derivative. So I go and say, well, let's just do this, right? It's a power rule. So it's 3 times x. 3 minus 1 is 2 to the second power. Okay, minus the 5x squared, minus. Okay, so 2 times 5 is 10. x to the first power. Okay, cool. Y double prime is equal to 2 times 3, that's 6x squared, not x squared, x minus 10. So here's what I want you to do. I want you to do y triple prime, which is the third derivative, and y to the fourth prime. No, it's not 4 tick marks. Usually what they do is they put it in parentheses here like that, to the fourth. Okay, so as you know, it's the fourth derivative. I want you to find those two while I go ahead and I pause my video. And bada bing, there you are. Hopefully you got the right answers. Hopefully this is starting to click with you of how these rules work. All right, and now that we've stopped it, here's your homework. Okay, notice on your thing it should section 3 point. It's not 3 point. It's really 3.3. Okay, just like last time I kind of messed up. Okay, page 124. That's the right page number. Everything else is right. Good luck. God bless. If you have any questions, you know what to do. Where to type them. Do it now.